Hey, sixth grade. Today we are looking at the fundamental counting principle and what that really means. So, I'm on page 757. So here's the explanation the book gives for fundamental counting principle on 758. And it says right here, top of the page, if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible outcomes. And yeah, so, I really wonder what that really means. Let's find out. If you look down here on the next example there, it talks about what it means, and it shows that you're going to be tossing a coin and then rolling a number cube. Rolling a number cube. Yeah, there you go. So, tossing the coin has two possibilities. And we've seen this sample space stuff before. And after you roll or toss the coin, then you have 6 choices for each thing. So that means there would be 6 for heads and 6 for tails. Altogether, if you look at those on page 758, you should see 12. And so that means if you have 2 choices for the coin, 6 for the number cube, total of 12. That's how many possibilities you have. That's how it works. The fundamental counting principle is you have 2 choices for the first thing, 6 for the second, 2 times 6, 12. So then they have some examples on 759. They're saying that we're rolling a number cube and then choosing a letter from the word numbers. So number cube has 6 choices. The letters, there are 7 letters. And then that tells you 6 times 7, there'd be 42 choices. And then you need to know the probability of rolling a 6 and choosing an M. So this is where you get what we've talked about before, where on the first one you have 1 out of 6, and on the second one you have 1 out of 7, because there's only 1 6 on the number cube, the dice, and 1 letter M. So that is compound probability, 1/6 times 1/7. That's where you get this 1 out of 42 right there. Now going down a little more, maybe. This one is about jeans. So, wow, this is interesting. So you have the waist size right there, the length, and the style. So it looks like we have 5 different sizes, 3 different lengths, 3 different styles. So yes, you can do more than one, 5 times 3 times 3. And then you have to look and see about the probability. And so they're saying a 32 by 34 slim fit. So that means when you get 32 by 34, that means 32 is the waist, 34 is the length, and then slim is the style. So there's only one 32 out of the 5. There's only one 34 out of the length, 3 lengths, and there's only one slim out of the 3. So that's where you get 1 times 1 times 1 on top. And 5 times 3 is 15 times 3. That's 1 over 45. And we said that's about 2%. So there you go. Let's keep going. This is a good one down at the bottom here too. I want to clear everything else off and then see what's going on. So here's the example down here of the problem. See if you've got it. And it says 2 number cubes are rolled. What's the probability that the sum of the numbers of the cubes is 12? And then how likely is that sum? Is it that the sum would be 12? So first of all, you have two things. You have 6 sides on the first die and 6 on the second. So you know there are going to be 36 choices altogether. Now, this is one where you do have to be able to figure out how many ways would there be to get an answer of 12. And there's only one way to get an answer of 12, and that's 6 and 6. There's only 1 6 and only 1 6 on each one. So again, 1 times 1 on the top is 1. 6 times 6, that's where you get the 36. And that's not very likely. I think it's almost exactly what the book says here if I turn the answers on. Right there. 1 over 36, 3%, very unlikely. So let's see if these guided practice ones make sense before we show you what to do. And it says first, fundamental counting principle. I want to make that a little bigger. There we go. Use the fundamental counting principle to find the number of outcomes, tossing a quarter, a dime, and a nickel. So, for a quarter, there are 2 choices. Heads or tails, dime, 2 choices. Nickel, 2 choices. 2 times 2 times 2, that's where they get 8. So here's the outcomes for rolling a number cube and then picking a cube from 4 different colored cubes. Well, for rolling a number cube, you have 6 choices. Picking a cube from 4 different colored cubes, there are 4 choices. 6 times 4, 24. Number 3 here says, let's see, we have 3 sweaters, 4 blouses, and 6 skirts. And then it says, find out how many there are altogether. Well, that would just be 3 times 4 times 6. That's 3 times 4 is 12 times 6. That's where they get the 72. And then they say probability of getting a particular combination. That means like one of each. So again, if it's 72 choices, it'd be 1 over 72 if you're just saying that there's 1. And there you go, and it's unlikely. I'm surprised they don't say very unlikely. There we go. Clear that off. Look at one more here. All right. Whoa, that was weird. Not what I wanted to have happen. Okay. And then this is interesting because it does say, tree diagrams show specific outcomes. Fundamental counting principle is a faster way to obtain the number of outcomes. All right, let's take a look and get you started. So we're going to do 1, 2, 3, and 4. These are just using fundamental counting principle to find out total number of outcomes for each one. So you just have to see, how many bagels, how many cream cheese, multiply. Same things for 2, 3, and 4. 5, number of possible routes. And then it does ask for a probability, so make sure you pay attention to that. So you do need to find number of possible routes from Eastland to Johnstown. So you have to look how many choices are there from here to, whoa, holy cow. How many choices are there from here to there, and how many from there to there? And then, then they give you a specific one to look at. Number 6, 2-digit password. Find the number of possible choices for a 2-digit password that is greater than 19. So you've got to think, you've got 2 digits. You've got 2 digits. How many would there be if it's got to be greater than 19? How many numbers could there be in the first part? How many numbers could there be in the second part? It's got to be higher than 19. Interesting. And then it says find the number of possible choices for a 4-digit personal identification number if the digits cannot be repeated. Wow, that's pretty interesting. I like that one. So the 4-digit one, I can give you a hint on that one anyway. See what you get. See how it goes. And we can always look at these on Monday. So how many numbers could you get in the first box? I think you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a single digit, so there'd be 10 in the first box. All right, so you'd have your first choice would be 10. Then Second box, can't repeat it, so you don't have 10 choices and we only have 9. Almost like you'd have to multiply all of those. And then this one with the 2-digit one, though, you might try the same way, but then you got to think about how many numbers you couldn't have. A 2-digit password, I think I know how many there'd be, but it's got to be greater than 19, so you might need to eliminate certain ones there. That'd be interesting to see what you get for that. See how that goes. Number 7 says they're making 5 subjects, an app for 5 subjects, including math. Great. The app has 10 versions with a different avatar in each version. One version has an avatar that looks like a lion. The company is randomly giving free apps to its customers. What's the probability of randomly receiving a math app with a lion avatar? Okay. Yeah, you can get the probability for that. You just got to think. For the subject, how many choices do you have? For the app, how many choices do you have? And then avatars, and how many would be lions? And no problem. There you go. Let's go to the next page. Number 8's a good one. You can do number 8. This one talks about you have the meat. Where's my pen? You have the meat. You have the cheese. And then they want to know how many breads should you use, because they give you the total number of choices. You just got to figure that one out, okay? Let's see what you think about 9. It says what it says. See what you think. If it would be true. Let's look at persevere. Tossing 1 coin, 2 coins, and 3 coins. And then for tossing n coins. Interesting. I want to see what you come up with that. Talk with people about this one and see if you can figure out, how many outcomes are there if you have 1 coin. Okay? And see what you get for, if you don't even know the number, what would it look like? See what you think. That's an interesting one. Just do the best you can on that. See how it goes. Whoa, that was weird. Don't know what's going on. Okay, let's try this again. I still don't. Oh, no, stop it. What is going on? All right, I'm trying this again. Okay, we talked about that in that one. Okay, 11. 11, I think you'll get 11. You should try 11. It's pretty simple. 12, same thing. Should be pretty good if you figure it out. Talks about number of cakes, number of icing, and then number of designs. Oh, wow. It's good. See what you think on that one, too. All right. One more page to take a quick look at. All right. Now, these would all be really simple. I would say take a look at all of them on this page. And then 19 and 20. Let's see if there's anything weird on 19 and 20. So this one says it has, number 19 has oranges, apples, and bananas. It offers peas, green beans, and carrots. So you have fruit and you have a vegetable. Find the number of fruit and vegetable options. If the fruit and the vegetable are chosen at random, what's probably getting orange and carrots? Is it likely or unlikely to get an orange and carrots? Okay, I see. Yeah. So, how many choices are there? How many choices out of the fruit are oranges and how many choices of the vegetables are carrots? I think you can get that one figured out. See how it goes. The last one, number 20. I think it's the last one. Yeah. Wow, they gave you a whole 4 lines. It must be a paragraph. So, cell phone options. You have some brands. Looks like you have 3 brands and 3 payment plans. Wait, is that 4 payment plans? I didn't see that business and government were different. And then you have 4 accessories. 1 payment plan and 1 accessory given away at random. What's the probability that brand B will have a headset? Interesting. See what you think on that, and we'll talk about that one too. That's okay, because you notice they talk about the brand, and there's only one brand to be out of those choices, and there's one headset out of the accessories. But then they don't say anything about the plan. How do you take care of that? All right, so there you go. Hopefully you know every part that you're doing. I think basically we did 1 through 20, but I think there was something I left out, like the one about what doesn't belong. You could take a look at that. It doesn't matter. But that's about it. So you have the rest of the time to work on it, see how it goes.